2025 A-Level Combined Mathematics Paper 1, Part B, question number 17, Part A. Part B of this same question will be discussed in a future video, link in the top right, and Part C of this question will also be discussed in a future video, link in the top right. Parts A, B and C of question number 17 all usually have to deal with trigonometry and trigonometric functions. Part A says, write down sine of A plus B in terms of sine of A, sine of B, cosine of A and cosine of B. It then says, deduce that the sine of 2 times theta is equal to 2 times the sine of theta times the cosine of theta. Now after this, it says, let the value theta be some value in between 0 and pi by 2. So theta is some real value between 0 and pi by 2. Given this, it says, express the equation cot theta minus 2 tan theta equals sine of 2 theta in the form of A times cosine to the power of 4th theta plus B times cosine squared theta plus C equals 0. So we have basically a quadratic in terms of cosine squared theta where A, B and C are real constants. Finally, it says, hence show that theta is equal to the cosine inverse of the square root of 17 minus 1 divided by 4. So to start off this question, if you look at the first line, it says write down sine of A plus B, and due to this we don't actually have to prove anything. We can just use the identity that we know that we found in our video on trigonometric identities and directly say that from the first part we get sine of A plus B equals, and we can directly write the identity that is equal to the sine of A times the cosine of B plus the cosine of A times the sine of B, or alternatively you might sometimes write this as the sine of B times the cosine of A. So now we have this. The next line says, deduce that sine 2 theta is equal to 2 sine theta cos theta. Now if we take a look at what we have, this identity that we just wrote down and what we are expected to find, we can see if you substitute A as theta and also substitute B as theta, we can see we're going to get sine of theta plus theta on the left hand side, and on the right hand side we're going to have sine of theta cosine of theta plus cosine of theta times sine of theta, which will get us what we want. So therefore what we're expected to do here is to let A be equal to theta and B be equal to theta, as in A equal B equal theta, and then substitute into that thing in order to show this identity here. So we'll say let A equal B equal theta and consider what happens. So then we get on the left hand side sine of theta plus theta, and on the right hand side we get sine of A is theta, so sine theta times cosine of B is also theta, so cosine of theta plus cosine of theta times sine of theta. Now cleaning this up, we can see on the left hand side we have sine of 2 times theta is equal to, and on the right side we have sine times cosine of theta plus cosine of theta times sine of theta. So both of these are the same exact thing. It's just sine of theta times cosine of theta plus sine of theta times cosine of theta, which is going to be 2 times sine of theta times cosine of theta. And hence we have shown that sine of 2 theta is equal to 2 times sine of theta times cosine of theta. Now after this, we have to let theta be some value in between 0 and pi by 2. So we'll say let theta be some value in between 0 and pi by 2. Now given this, it asks us to simplify this thing down into this form where we have a quadratic in terms of cosine squared theta. So we have to start with cot theta minus 2 tan theta equals sine 2 theta and simplify down to only have cosine of theta as our trigonometric function on the inside. So if we consider this thing, we have cot theta minus 2 times tan theta equal sine of 2 theta. Now for this range of theta in between 0 and pi by 2, we can see since theta is not equal to 0, cot theta is not equal to infinity, as in it's not equal to plus or minus infinity, or it's not equal to an undefined value. And similarly, since theta is not equal to pi by 2, tan theta is also not going to be either infinity or negative infinity, as in the undefined value. So due to this, we can say in this line, cot theta is defined and tan theta is also defined. We can say this due to the fact that the range of theta does not include theta equals 0, which would cause cot theta to be undefined, and it does not include theta equals pi by 2, which would cause tan theta to be undefined. So with that, we can now say that this is in fact a possible equation. So now with this possible equation, let's try to solve it. So to solve it, as they said above, we need to convert everything into only having cosine of theta. To do that, what I'm going to do is to substitute cot theta for cos theta divided by sin theta. And I'm then going to substitute tan theta for sin theta divided by cos theta. And I'm then going to substitute sine of 2 theta for what we had above, which was 2 times sine of theta times cosine of theta. So now we have this thing right here. We can see if you multiply everything by sine of theta times cosine of theta, all denominators get deleted. This denominator is going to get removed, and so is this one. So if we do that, we can see on the left hand side, we get cosine of theta times cosine of theta, or cosine squared theta, and then we get minus 2 times sine squared theta, so minus 2 sine squared theta being equal to, and on the right side here, we get 2 times sine squared theta times cosine squared theta. Now for the next step, in order to get rid of all of the sine squares and only have cosine squares in this equation, what we're going to do is use the identity, which I'm actually going to write down here, saying that sine squared theta plus cosine squared theta is equal to 1, and hence sine squared theta is equal to 1 minus cosine squared theta. So we're going to substitute this identity in for every single value of sine squared theta to get rid of all sine squared thetas and only have an equation in terms of cosine squared theta. So then we're going to get cosine squared theta minus cosine squared theta minus 2 times 1 minus cosine squared theta equal to 2 times 1 minus cosine squared theta times cosine squared theta. Now if we simplify all of this down, we can see we're going to get cosine squared theta minus 2 plus 2 cosine squared theta equal to 2 cosine squared theta minus 2 cosine to the power of 4 theta. We can see we've already got the quadratic that we wanted, but now we need to clean everything up by taking everything to one side. So what I'm going to do is to take the right hand side to the left hand side and simplify everything down. If I do that, this 2 times cosine squared theta is going to cancel with this 2 times cosine squared theta. We're going to be left with 2 cosine to the power of 4 theta plus cosine squared theta minus 2 equals 0. So therefore, if we go to the next line, in the next page, we can see we're going to get 2 times cosine to the power of 4 theta plus cosine squared theta minus 2 equals 0, which is of the form a times cosine to the power of 4 theta plus b times cosine squared theta plus c equals 0, where a is equal to 2, b is equal to 1, and c is equal to negative 2. So we have our answer. Now what we need to do finally is to finally show that theta is equal to the cosine inverse of the square root of 17 minus 1 divided by 4. Now in order to do this, as you might have guessed, we're going to be using the quadratic formula to solve for cosine squared theta and then simplify down until we get theta. So doing that, we can see from above 2 times cosine squared theta squared plus cosine squared theta minus 2 is equal to 0, and hence if we apply the quadratic formula, the cosine square of theta is going to be equal to negative b, which is going to be negative 1, plus or minus the square root of b squared minus 4ac, which is going to be 1 squared minus 4 times a, which is 2, times c, which is going to be negative 2, divided by 2a, which is going to be divided by 2 times 2. Now simplifying down, we can see cosine squared theta is going to be equal to negative 1 plus or minus the square root of, if we look at the inside, we can see we're going to get 1 minus minus, which is going to be plus, and this is going to be 16. So 1 plus 16 is 17. So 1 minus 1 plus or minus square root of 17 divided by 4. Now we can see we have on the left hand side cosine squared of theta, and on the right hand side we have two values. Out of these two values, one of the values, the minus value, is going to give the whole expression a negative value. The other value, the plus value, is going to give the whole expression a positive value. So therefore, we want the positive value, since on the left hand side cosine squared is always going to be positive. So therefore, we can say that cosine squared theta is going to be equal to minus 1 plus square root of 17 over 4, and we can say since cosine squared theta greater than 0. So now given this, we can now find, actually maybe we want to put greater than or equal to 0. Actually no, we have to put greater than 0, since we above it said that theta is in between 0 and pi by 2. So the exact value of pi by 2 will give us cosine of theta equals 0. but since it's not equal here, we have to put that it is in fact greater than 0 and not greater than or equal to 0. So anyway, moving on from that, we now have that cosine squared theta is equal to -1 plus the square root of 17 over 4. Now, we can get from this that cosine of theta is equal to the square root of -1 plus square root of 17 over 4. Now, how do we know this is equal to the plus square root of this and not the minus square root of this? Well, once again, we have to use the fact that cosine of theta is also greater than 0 as theta is in between 0 and pi by 2. So for this range of values of theta, cosine theta is always going to be positive, which means that if we consider cosine squared, the square root of this thing plus or minus is going to be what cosine theta is equal to. But since we know that cosine theta is also going to be positive for the range from 0 to pi by 2, we know that is going to be the positive square root. Now finally, from this we can go to theta being equal to the cosine inverse of the square root of, we'll put in the format that they have, square root of 17 minus 1 divided by 4. And we know this since, once again, since theta is in between 0 and pi by 2. Finally, if you consider the marks of what if this question, at the start when you write down the identity of sine of a plus b in terms of sine of a, sine of b, cosine of a and cosine of b, you get 5 marks. When you then substitute into that a equals b equals theta in order to obtain sine of 2 theta is equal to 2 sine theta cos theta, you get another 5 marks. After that, when you're given this expression cot theta minus 2 tan theta equals sine 2 theta, for your first substitution where you substitute cot theta for cos theta divided by sine theta and tan theta for sine theta divided by cos theta, you get 5 marks. For your next step, when you then multiply everything by sine of theta times cosine of theta in order to eliminate all the denominators that you have, and you get this expression here, as in you multiply everything here by sine of theta times cosine of theta, for that step you get 5 marks. After that, when you get to this expression right here and you use the identity that sine squared theta plus cosine squared theta is equal to 1 in order to substitute all sine squared thetas for terms in terms of cosine squared theta, and you get this substitution right here, you get a full 10 marks for that. When you then simplify the entire expression down in order to get a quadratic of this form right like this, you get another 5 marks. When you then solve the quadratic using the quadratic formula and do all of this work, obtain the two roots and say that since cosine squared theta is positive, only this root is correct, you get 10 marks for all of that work. After that, when you then take this thing, when you take the square root of both sides and realize that since cosine of theta is positive as theta is in between 0 and pi by 2, cosine of theta is going to be equal to the positive square root of minus 1 plus square root of 17 divided by 4, you get 5 marks. When you then finally say that since theta is in between 0 and pi by 2, we can just directly take the cosine inverse of both sides and say that theta is directly equal to the cosine inverse of the square root of the square root of 17 minus 1 divided by 4, you finally get your last 5 marks. So that is going to be all for this question and all for this video. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.